All right, so we're now into chapter 10. And chapter 10 is just a bunch of applications of trigonometry. We're only going to talk about 10.1 and 10.2, law of sines and law of cosines. The other stuff in chapter 10 is really, really cool, but we're going to be spending the rest of this class with algebra, okay? So 10.1, 10.2, law of sines, law of cosines, respectively. What is the law of sines? If you want the answer to that question, you came to the right place. I'll be honest, if you just want to use it without knowing what it is or where it comes from, you can just skip to the next video. But I highly recommend, especially if you're planning on going further into mathematics, highly recommend looking at this video and seeing where it comes from and the logical problem-solving approach that we use to derive this. All right, because it's pretty cool and it won't take that long. I guess you know how long it's going to take better than I do. I can't look into the future and see how long this video is, but you can. But who knows? Maybe the last 5 minutes of the video is just me talking about my cat. That's entirely possible. So example 1 says, solve for A. And let's say there's some triangle. This is not a right triangle. Let's label it alpha, beta. As you write, my beta is kind of like this with a long tail, and a little squiggle, and gamma, which kind of looks like a little Y. And now this angle is 32 degrees. This angle over here is going to be 28 degrees. And this is B, which is 3 inches. Something that's very common is B is opposite beta. So A is going to be opposite alpha. And that's what we want to solve. And the hint here is that if we look at this H here, H is going to split us into 2 right triangles, right? This is a right triangle right here. And this is a right triangle right here. So even though this big triangle is not right, we can think about it as 2 little right triangles. Okay? So let's do that. So let's use everything that we know. We're going to have 2 triangles. They're both going to have to do with H. This is going to be a system of equations. So let's look at this first triangle. How do we relate these 3 things together? Sine. We got the opposite. We got the hypotenuse. We're going to need sine. So in this red triangle, we're going to say that the sine of 32 degrees, you need to include units. If you don't write units, that means 32 radians. As a side note, you might want to switch your calculator back into degrees. We're going to be using degrees almost exclusively in chapter 10. Is equal to the opposite over the hypotenuse. Why is this helpful? We don't care about H, we care about A. It's helpful because of this blue triangle. This blue triangle says that the sine of 28 degrees is the opposite over 8. So this blue triangle is really what we care about because we care about A. But the problem is this H. We need to know what H is. How do we find what H is? The red triangle. Okay. So if we move things around, multiply by 3, we get H is equal to 3 times the sine of 32 degrees. We also get that H is equal to A times the sine of 28 degrees. If H is one thing and it's the other thing, then those things must be the same. So specifically, 3 sine of 32 degrees equals A sine of 28 degrees. And this step right here, we're not done with the problem yet. This step right here is basically the law of sines. The law of sines, basically. So the law of sines really just comes from splitting any triangle into two right triangles. But we can finish the problem. How do we solve for a? Divide both sides by the sine of 28 degrees. A is 3 sine of 32 degrees divided by the sine of 28 degrees. Like so. And you could approximate it. Desmos only takes in radians unless you do some other things. So you can also do this with Google. So Google is going to be useful right here. Sine of 28 degrees. You can just type in DEG. Divided by, oops, A is 3. Oh, I'm not even typing in the right thing. A is equal to 3 times the sine of 32 degrees. 3 times the sine of 32 degrees divided by the sine of 28 degrees. That's going to give us about 3.3863 inches. As a side note, the side opposite an angle, the bigger the side, the bigger the angle. So A should be bigger than 3 because 32 degrees is bigger than 28. All right. So let's formalize this. I said this is the law of sines basically. Let's actually introduce what the law of sines is. Again, it's here. I'll just kind of go into it. The law of sines says that the ratio of the sine of any angle with its opposite side is the same for any single pair. All three of these ratios are the same. And we can use any pair. So when I said that we basically had the law of sines before, it was this that we basically had, right? This green box. If we divided both sides by 3a, we divided both sides by 3a, what would we get? We'd get the sine of 32 degrees. The 3's would cancel and we just have a. Sine of 28 degrees. The a's would cancel, we just have 3. So you can see it right here. The ratio of the sine of this angle with its opposite side is the same as the ratio of the sine of this angle and its opposite side. It just comes from systems of equations. And you can do the same thing to get that third pair as well. With the third pair, you'd draw like another triangle, like here or something. No, not right there. It would be oh, because of the dimensions of this one, it'd actually be kind of weird to draw the third triangle. Third triangle, you'd have to extend one of the sides like this. Okay, and get two triangles in a slightly different way. Okay, so that's the law of sines right here. That's it. We'll actually do some problems in the next video.